Hello everyone. Today Knowledge Hub has come with a question related to projectile motion. So today I'm going to teach you how to solve any query, any question related to projectile motion, whether it be horizontal projectile motion or angular projectile motion. So guys, the question is that there is a projectile which is launched from the top of a building and the height of the building is given to be 200 meters above the ground and the launch velocity is 50 meters per second with the angle of 20 degrees from the horizontal. So we have to calculate three things. The first one is the range, which is the horizontal displacement of the projectile. Then there is peak height, which is vertical displacement during the maximum vertical displacement during this motion. And the last part is we have to find the velocity after 2 seconds. Well guys, the question says that you are standing on the top of a building whose height is 200 meters from the ground, right? Now, suppose you are standing here and you are going to throw the ball and it is going to follow a parabolic path, which is my projectile motion. Now, he says that the angle at which the object is thrown is 20 degrees, right? And the velocity with which it is thrown is 50 meters per second. Now, this horizontal displacement is nothing but the range, and at this highest point, when the object reaches at this highest point, this vertical displacement is your peak height, which is the second part of the question. Now, let's say after 2 seconds the object reaches at this point B. So at this point the velocity will be v. So you have to find this velocity, which is your c part. Now, because the initial step to solve any numerical is that you have to write down all the knowns and unknowns. So my known is my initial height is 200 meters. Initial launch velocity is 50 meters per second. Because it's a vector quantity, so I can find its horizontal and vertical components, which is u cos theta, which is 50 times cos of 20 degrees. Why? Because my angle is 20 degrees, right? Now, this comes out to be 46.98 meters per second. Now, the next step is that you have to find the vertical component of initial velocity, which is nothing but u sine theta, right? So u is again 50 times sine of 20. On solving this, you'll get 17.10 meters per second as your initial velocity, right? Now, the next step is, what is your horizontal component of acceleration throughout the motion? It is 0. Reason being, the only acceleration is in the downward direction, which would be negative 9.8 meters per second, which is acceleration due to gravity. So I have written all the known variables. So these are nothing but the known variables, right? Now, what you have to find is range, height, peak height, and velocity after 2 seconds. So I have written all the known and the unknown variables. Now, two very important equations that I'm going to use to solve this question is S equals to ut plus half at squared, and another one is v equals to u plus at, right? Now I am going to consider the x direction and y direction separately, and I'm going to prepare a toolbox to solve this numerical. Toolbox means all the equations that I need to solve this this question, right? Now for the x direction, again I'll be using both of this equation 1 and equation 2. Now let's say my horizontal component of displacement is x, then this x equals to uxt plus half axt squared, right? Now this t is nothing but the time of flight and x is nothing but the range. So ux was nothing but 46.98 times t plus 0, right? So range comes out to be 46.98 t, right? So let's say this is my third equation. Now the second equation is vx equals to ux plus axt, right? So what was my ux? 46.98 meters per second. So that means throughout the motion the horizontal component of velocity remains the same. Reason being, my ax is 0. Okay, now let's go to vertical direction, right? Now in vertical direction again, y equals to uyt plus half a by t squared. Again, t is time of flight. Now y is nothing but in the initial it is negative 200, right? Now why I am taking negative 200? You are standing at this point and you are going to throw it in the upward direction and it follows the parabolic path. Now this point A is considered as origin, so this is the negative y direction and upward is the positive y direction. So because this towards the negative y direction the distance is 200, so I'm going to take it as negative 200. This equals to again uy was 17.10 times t plus half. Now ay was negative 9.8, so t squared, right? So this is nothing but a quadratic in t. So on solving this quadratic you are going to get two values. One is 8.4 seconds, another is negative 4.9 seconds. Now time can never be negative, so my time of flight for the whole of this motion is t equals to 8.4 seconds. Let's say this is fourth equation, right? Now my first part was to find the range. So range, the formula was 40, the third equation was range is 46.9 times t. T is time of flight and I have found the time of flight as 8.4. So when I solve this, I'm going to get, let's calculate in the calculator. So what are we going to get? 46.98 times 8.4, right? So I'm going to get the approximate value as 394.63 meters, right? So this is my range. So I have solved a part. So the second part was to find the peak height, which is, now you know that you were standing here on the top of the building and this was my motion. Now to find the peak height, I'm going to consider my motion from point A to point B, right? Now let's just find the time the projectile takes to go from point A to B, right? At point B, at the highest point, the vertical component of velocity is 0 because you are going against the gravity. So when you go against the gravity, your velocity first decreases, right? So let's find the time that it is going to take in going from point A to B. Now I'm going to apply this equation. Now Vy at B was 0, Uy was 17.1 minus 9.8 times t. So from here I am going to get time as 1.74 seconds, right? Now we have found the time as 1.4 seconds in going from point A to point B, and we have to find this height, right? So obviously in this much time it reaches the maximum height. So because it is height, which is vertical component of displacement, I'm going to consider just the vertical components to solve the peak height. Now what was your uy? It's 17.1 and t is the time it takes to go from A to B, right? Then plus half ay was negative 9.8 times t square is 1.74. So on solving this, I'm going to get height as 15 meters. So I am successful in calculating part B of projectile motion. So let's work out with the last part, which is to find the velocity after 2 seconds, right? So again, I'm going to draw the diagram, which was like this. Let's say the particle or the object is at this point. Let's say this point is B, and you have to find this velocity. Now I'm going to break this velocity because it's a vector quantity into horizontal and vertical components. So I'm going to first calculate this horizontal and vertical components. Now Vx was ux, which is 46.98 meters per second. Why? Because Acceleration in that direction is 0, so velocity remains constant in horizontal direction throughout my motion. Now I'm going to work out for the vertical component, which is Vy equals to Uy plus Ayt. Now Uy is 17.1 plus negative 9.8, and time after which I have to find this component is 2 seconds. Now on solving this, I'm going to get answer is negative 2.5 meters per second. Now why this is negative? Now can you look here at point B, the vertical component is in the negative y direction, so this means that this is negative. Now to work out for the resultant velocity, you'll apply vector analysis, which is vx square plus vy square whole square root. So I'm going to substitute the value of vy as negative 2.5 and vx as 46.98, and on substituting I'm going to get answer as approximately 47 meters per second. Now because velocity is a vector quantity, so I need to find the direction as well. So I have just found the magnitude. To find this velocity, the direction for this velocity, the formula is theta equals to tangent inverse Vy by Vx. This how do I come to know that this is the formula? See, look here. This is my velocity vector, this is my Vx, and this is component Vy, and this is angle theta. So you apply the trigonometric identities and you get tangent theta as Vy by Vx. So from here I'm going to get this formula. So when I substitute Vy and Vx, the theta comes out to be 3 degrees. So that completes my part C. So we have done horizontal range, peak, height, and the velocity after some time t, which is 2 seconds in this case. So guys, if you have understood how to solve this projectile motion questions, please subscribe my channel and press the bell icon button to get the daily notifications for more upcoming videos. Till then guys, stay happy, stay safe.